Hey guys, today we're taking a look at section 4.3, which is about rotations of geometric figure in the coordinate plane. So let's take a look at our learning targets. First of all, we are looking to perform rotations and composite rotations of geometric figures. And then we also want to be able to identify what rotational symmetry is. So recall a few sections ago we talked about a rotation as a turn. It is simply a transformation in which the figure is rotated or turned a certain degrees around a fixed point called the center of rotation. Rotations can turn clockwise and counterclockwise. However, you should note that when we do a rotation, a positive degrees, it is going in the counterclockwise direction. And when we are turning a negative degrees, it is going in the clockwise direction. So take a look at our example over here on the right hand side. You can see that we have a little flag denoted by this P, R, and the little triangle, and it is being rotated around the center point P. So the angle measure that it's being rotated here is this 40 degrees, and since we are moving in this counterclockwise direction, it is this positive 40 degrees. So the pre-image over here on the right hand side gets rotated over here to the left, and it is the R prime, Q prime. This little dotted flag is the image after that rotation of 40 degrees around the center point P. All right, let's look at some more common rotations that we'll be doing throughout this section. The most common ones are to rotate our geometric figure around the origin. So here are those rules for rotating around the origin, which remember is the point 0, 0. When point AB is rotated counterclockwise 90 degrees around the origin, all of those coordinates AB will go to now being negative BA. In other words, the x and the y will change places, and the former y value, which is now the x value, will change from positive to negative or from negative to positive. When we rotate 180 degrees around the origin, each xy coordinate, or AB coordinate, will now go to the opposite A, the opposite B. So they will both just change values, but they won't change places. When we rotate 270 degrees around the origin, we will have all of our AB coordinates go to B, comma, negative A. So notice now they do change places, and the former x value, which was A, changes value over here. So it is now either going to go from positive to negative, or if it started off negative, it will now be positive. And then finally, 360 degree rotation, well, that just maps itself back onto its original location. So all of our coordinates x, y, or AB are now back to AB again. Let's look at an example here and see how this works. We've got the quadrilateral WXYZ with vertices at 2, 1, 4, 0, 4, negative 2, and 3, negative 3. We want to graph its image after a rotation 90 degrees around the origin. So let's take a minute to plot our figure. Here's W, here is X, Y is 4, negative 2, and then Z is 3, negative 3. So here we go. Here is our figure. It looks something like this. All right, there's W, here is X, here is Y, and here is Z. We're going to do an image after a 90 degree rotation. So if you'd like, it's easy to do this by setting up a nice little T table here where you have your pre-image coordinates, W, X, Y, and Z. W is 2, 1. X is 4, 0. Y is 4, negative 2. And Z is 3, negative 3. Now remember, our rule up here says we're going to take all of those xy coordinates, they're going to switch positions, and that new x coordinate, which was your former y coordinate, is going to change value. So let's list out W prime, X prime, Y prime, and Z prime. And now let's do the transformation on that. So W prime is going to go now to negative 1, 2. X prime is going to go to 0, 4. y prime is going to go to positive 2, 4, and z prime is going to go to positive 3, 3. All right, let's take a look and plot those figures now. Here's negative 1, 2, 0, 4, 2, 4, and finally 3, 3. All right, so if we connect those points with nice straight lines, we will get a figure that's been rotated 90 degrees. So you can see here how this comes up this counterclockwise direction to give us that that 90 degree rotation around the center point here, that origin. So here is W prime, X prime, oops, let's get that right, X prime, Y prime, and Z prime. There is our image quadrilateral. All right, let's do another example here. Now we're going to rotate this one 180 degrees around the origin. So I'm going to list out my coordinates again. That helps me to be able to do that transformation. So we've got 2, 1, 4, 0, 4, negative 2, and finally 3, negative 3. Now remember, when we do a rotation of 180 degrees, all of our x, y coordinates are just going to change value. They're going to go to the opposite of x, the opposite of y. All right, so W prime, X prime, Y prime, and Z prime. Let's write out those coordinates. These are going to both change value, so it'll be negative 2, negative 1. X prime will change value, negative 4 and 0, because 0 is neither positive nor negative. Y is at negative 4, positive 2 now, and then Z is negative 3, positive 3. Okay, so if you were to plot this out here, take a second to do that, plot both the pre-image and the image, and you should see a 180 degree rotation. All right, moving on to our notes here, we've got another definition on rotational symmetry. A rotational symmetry is a figure that is said to have this sort of rotational symmetry if it can be copied onto itself by a rotation of 180 degrees or less around the center of the figure. So take a look at the fan over here on the right hand side, and you will see that this has rotational symmetry. If I can take this and turn this figure just 90 degrees, it will map itself back onto the original image. So not at 45 degrees, because these two images look different, but here at 90 degrees, this first and third fan here, if this is our second and fourth, looks exactly the same. So we say that this has a 90 degree rotational symmetry. All right, let's take a look at our examples down below here and see if we have some rotational symmetry for example 3. Well, in our first one over here, we can see that if we rotate this arm over here to this side, then that X will appear exactly as it does right here. So that's going to be 1 rotation. Here is 2 rotations, 3 and 4. So to figure out the degree of the rotational symmetry, we're going to take the full 360 degrees and divide it by the number of times it rotates on top of itself. And 360 divided by 4 is equal to 90 degrees. So just like our fan up in the first example, this has a 90 degree rotational symmetry. All right, let's look at our little flower here. If we rotate this leaf up here to the top, that will map itself back onto the original figure. So that's 1 rotation. Here's a second, third, fourth, 5th, and 6th. So to find the rotational symmetry, or the degree of rotational symmetry, we're going to take 360 degrees and we're going to divide it by 6. When we do that, we get 60 degrees. So we say this has rotational symmetry of 60 degrees. All right, next up is this heart, and we should just go ahead and put math right inside that heart because we all love math. All right, the degree of symmetry here, we can't rotate this heart. If we do, rotate it, it's not going to look the same, right? Let's see if I can draw this sideways heart here. Now, if we rotated it 90 degrees, that heart would look like that. That does not look the same. If we rotated it 180 degrees, it would look like, oh boy, that's not a good heart. But anyways, you get the idea. It'd be upside down. That does not look the same as that. So this is just not rotationally, that's not rotationally, rotationally. All right, you got this, rotationally symmetric. All right. How about for our final example, the star? And yes, this is going to be rotationally symmetric. If we rotate this point up here, over here, over here, one more time, back around, we get 360 degrees divided by 5. And you tell me, I believe that is 72 degrees of rotational symmetry. All right, guys, just got one more example for today, and this is a composite transformation. Remember, a composite is a transformation, two or more transformations happening in combination. So here an example for us is to complete this composite transformation on the pre-image triangle ABC following these transformation rules. All right, we're going to start off by graphing triangle ABC. A is at -5, 2. B is at -3, 5, and C is at -1, 1. All right, so here we go, A to B, B to C, and C back to A. There we go, A, B, C. We are going to perform these two transformations. We're going to do a translation, which is a slide, left 1, up 2. Remember the rule here that we're going to subtract 1s from our x's and add 2 to our y's. And then we're going to do a reflection in the x-axis. That's where we change the value on the y-coordinate. And then we're going to do a rotation of 180 degrees around the origin, and that's where both of those swap spots. So let's go through one coordinate here, and then I'm going to let you guys try this one on your own. If we translate our first coordinate A to A prime, by doing the -1 to the x and the adding 2 to the y, then we'll subtract 1 from -5. That puts us at -6. And then we're going to add 2 to the y value, which puts us at 4. All right, next we're going to reflect that over the x-axis, which means we have to change the value on the y. And we're going to change the value of the A prime coordinate. So now this goes to A double prime. This is our second transformation on it. And nothing happens to our x-coordinate. It says -6, but now our y-coordinate is -4. Okay, now we're going to rotate that around the origin 180 degrees. So we are rotating our A double prime coordinate to get A triple prime. And 180 degree rotation just means we're swapping both of those places. So that's going to give me -4, -6. So -4, -6 is going to be down here. Here is going to be a triple prime. All right, to pause the video, go ahead and fill out the rest of this table and graph B triple prime, C triple prime to see what your resulting triangle looks like. Remember, it should look exactly the same as triangle ABC in terms of its shape. However, its location will be different.